Hi, so I'm Kevin Most. I'm going to be talking today about idiomatic interop, and the subtitle of that is with Kotlin and Java. I gave this talk originally at Kotlin Conf, so the with Kotlin was kind of implied, but now it kind of messes up the alliteration, so I'm keeping the title idiomatic interop on the slides. So one question I usually get about interop between Java and Kotlin is, well, Kotlin already has 100% interop, right? Interop being interoperability between Java and Kotlin, right? They're supposed to work perfectly together. It's true, but like any code base, you know, the interop story, just because it's there and it works, it doesn't necessarily work well. It can be nice. You can have good interop. You can have pretty, clumsy, not that great interop. It really depends on how you write your code. And while Kotlin was designed to interop perfectly with Java, so pretty much everything should work there, there's some features in Kotlin that Java won't be able to consume perfectly, or that might be consumed awkwardly. So I think it's good to do a quick show of hands to see like what the demographics of the room is. So who's using Kotlin in production in some way, shape, or form? Put your hands up and I guess keep them up. And now put them down if you're using some Java. Like keep them up only if you're using all Kotlin. If you're using 100% Kotlin. Okay. And so you don't really have to think about this much, but you might still if you're using other libraries, which I assume you are. So to some extent, we're all using some Java, or most of us are using some Java with our Kotlin. And then there's other classes of developers who have to think about it as well. So there's, I'd say, 3 classes of people who should really be thinking about this. So if you're a Java library developer, there's a growing number of your users that are using your code from Kotlin. And if you want your APIs to look nice, your SDKs to look nice, your frameworks, you should think about what it looks like in Kotlin as well. And if you're a Kotlin library developer, I see a few new Kotlin frameworks coming out, dependency injection frameworks like Codeine and like Vue frameworks like Anko. If you're making these Kotlin libraries, some of your users will probably still be in Java because there's this third class of users, which I think most of us fall into, which is users that work in a mixed code base, right? That's the class that I fell into for most of like the 2 or 3 years I've been using Kotlin. We drop it into, say, an Android app, but you don't just RF your entire legacy code base, right? You continue to work with all that Java code that you had. So most users are going to fall into one of these 3 classes, and so you really have to start to think about interop. And I would break down interop components, like traits of a good interop story, into 4 different categories. So interop should, like, above all, be safe, right? You should not have a class of bugs or crashes that occur just because of the interface between your Java and Kotlin. And your interop should also be performant, right? There's, for example, some code that you write in Kotlin and consume in Kotlin that's performant, and then if you go to consume that same Kotlin code in Java, it may not be performant for reasons that I'll dive into later. Your interop should also be readable, right? You shouldn't have clumsy class names or method names or strange ways of invoking methods, on static members that seem unusual and don't read well just because of the interop. There are ways around that, so you should think about that as well. And I think another important one is that your interop should be discoverable. So one of my favorite things about Kotlin is the great tooling. JetBrains writes amazing IDEs, and like Kotlin has worked very well in IntelliJ since 1.0.0, and that means that most of your users are probably just like typing a name that sounds like what they think they want and pressing control space and seeing what's there that autocompletes. And if your API doesn't autocomplete well, it really probably isn't written that well, right? So your users are relying on the IDE to autocomplete for them, and you should make your work discoverable in the IDE. So I'll run through like a bunch of different tips and tricks that I've come across while using Kotlin with Java to make this interop story more pleasant. So the first class is all these JVM annotations. This is like a set of annotations that really makes, like, they're low-hanging fruit. They're great, and you can add them to Kotlin code and almost immediately see great effects. So the JVM annotations are annotations that you put on Kotlin, and it tells the Kotlin compiler how that code should look in the bytecode, right, that's generated, the bytecode that Java sees. So the first annotation I'll go through quickly. Most users of Kotlin already probably know about these, but I'll run through them quickly. So there's the JVM overloads annotation, right? So let's say you have this Kotlin extension function. We all love extension functions, right? This is an extension on date, and it's a format method, and it takes a format string. It optionally takes a locale, or it falls back to your default locale, and it formats that date according to that format string. So your Java consumer might do something like this, right? They might pass in a date. This is how extension functions generally get exported into Java bytecode. the receiver moves into the first parameter of the function, and then all the other parameters just get pushed down one. So the date, which is the receiver, becomes the first parameter in Java, and then that format string becomes the second parameter, and our Java user is saying, okay, we don't want to pass a locale, I want to use the default one, so I'm going to omit that parameter. But then they see a compilation error, right? They get a red squiggly in IntelliJ, and if they hover over it, it says that, like, this locale has to be passed, right? It's not being passed. But you specified it as a default parameter, so you would think that your users don't have to pass it. But unfortunately, only one method actually gets exported into bytecode by default. It's the method containing all of the parameters, and the Kotlin compiler, when you call this method from Kotlin, would just put those default values in place when at the call site. So you really only have one method in bytecode. You don't actually have overloads in bytecode by default. So Java would have to pass all of the parameters. It would have to do this, essentially. It would have to pass the default locale as well. And that's kind of error-prone and verbose. Let's say you go and change how you specify this default locale. You're going to have to go back and refactor every site that passes default locale from Java and make sure that they all pass whatever the new way of computing the default locale is. So there's a simple fix, and it's just you annotate this method with @JVM overloads, and then two methods will be exported into the bytecode, one with the overload and one without. So now your Java can pass the locale if they want to, but they can also omit it, right? They'll have two overloads. They'll have the version with and without the locale. But this isn't really, it's not like a silver bullet. You shouldn't get carried away with this. So like, let's say you have this great, we all love Kotlin for data classes. Let's say you have this data class with like 5 optional parameters, right? And everyone who's already seen this is laughing and knows exactly what's going to happen next, right? So let's say they're all optional, right? You can make them all nullable. And then your Java goes to call it, and they hit, what is it, Control P or whatever to see the parameters list, and they see this, and they go, what is that? Like, that looks terrible. It's 4 nullable strings that could be, you could pass them out of order, right? And then an integer at the end. The ordering is not like telling you any semantic meaning about this. Let's say you just wanted to pass like gender. You'd have to pass null, 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 and then the gender string here, right? So this is bad, and you shouldn't do it, and it's what effective Java like calls a telescoping constructor, and you don't want telescoping constructors. So Josh Block said you should consider a builder in this case, right? And the same kind of logic applies here. Just because this is Kotlin doesn't mean that builders are like forbidden. If there's a situation where you're thinking about Java interoperability, you should really just consider falling back onto builder patterns in these cases, right? They're not a bad thing to use in Kotlin either. They work very well. They're still fluent, and your Java users won't have to suffer through this weird telescoping constructor. So that's JVM overloads. Another JVM annotation that's great is JVM static. It's used on companion objects and on named objects. You'll usually see it in companion objects. If you put it on a function or a val property, a read-only property, there's a static method generated in the bytecode that calls through to that companion object's fun or val. And on a var as well, it generates 2. It generates a get and a set method. So what that really means is like you kind of have to understand that Kotlin doesn't have a concept of statics. It has companion objects that are nested classes within your class. And a static field does get generated for that companion, but any static method on your companion by default is actually generated as a member function or property on that companion class. And that's a design decision that allowed them to do things like companions implementing interfaces, which you can't implement an interface for static members in Java. But what it basically means is you won't get these static properties in your bytecode by default. What you'll get is this. Let's say you have a user class and it has a create factory function. Your Java will have to call it like this. They'll have to call user.companion.create. And that companion is actually like, it's a field, and it has this uppercase companion syntax for some reason. That's just the design decision made. And then you call .create, which is actually a member function on that companion field. And it looks really weird, and your Java users will probably go user dot, and they'll see this field called uppercase C companion, and they'll go, I probably shouldn't touch that. Like, that looks like some weird internal thing. Who writes fields with upper camel case, right? So they'll probably not touch it, which is bad. It's bad for discoverability, and it just looks awful. So like, there's an easy fix, and if you annotate your fun with JVM static, your Java users will be able to call it like this, right? They'll be able to call user.create, and that's what they want to do. This is good. In my opinion, there's a little bit of noise here. Like, all I really care about is the fact that there's a class called user, and then the fact that there's a factory function called create. And from my Kotlin perspective, like, I'm nested 2 layers deep. Nobody really likes, I don't know if you can really tell, but I grayed out the rest of it because it's not important, right? Class user is important, and that fun is important. Everything else there is kind of noise for Kotlin, right? And you're nested 2 layers deep just to make this static function. What I really want, in my opinion, is I want to take advantage of Kotlin's top-level functions and move this create function up as a factory function so that Kotlin can call, maybe I'll rename it to create user as a top-level factory function, which looks better in Kotlin. But then this breaks my Java, right? Like Java won't get a user.create method. And it gets something pretty close. It gets, if you command space, autocomplete around enough, you'll see user kt.create from your Java, and you'll go like, what is that? That's not even a name that I recognized. And the reason for that is Kotlin was designed mostly with Interop in mind, and when they were designing the language, they said, okay, it's plausible that users will have a Java class and a Kotlin class named exactly the same way, and we don't want to cause collisions and break compilations, so in the bytecode, we're going to append kt to the end of all of our Kotlin classes for the sake of interoperability. But then this looks really ugly, right? So there is a fix. You can just annotate. You annotate your file. You actually don't annotate the class or the function or anything. This @file : syntax means you're annotating the whole file with the JVM name annotation. And what that means is the name of this file, we're going to export everything from this file into bytecode as user, right? The name will be, any top-level function will basically be attached to the user class. So now your Java users can actually call this as user.create, which is what they wanted. And you have this nice top-level function in Kotlin, and both sides will pretty much look as you want them to now. Another new one I want to touch on, it's not a complicated one, but it is new as of 1.2, so it's just good to know, is JVM default. And you only use it in interfaces on funds, vars, and vals that have a default implementation. And it basically just allows Java to use your default impl as well. Because Kotlin has always had default implementations since 1.0, and Java's had it since Java 1.8. So this was kind of, they explicitly added this feature so that they wouldn't break existing behavior, where they were not allowing Java to use your default implementation. So let's say you have some repository interface that by default just throws an exception, and for some reason maybe you want to implement it and use that default implementation in Java, you actually wouldn't be allowed to, right? I mean, it makes sense you would want to use it, right? Like there is a default implementation on that repository interface, and so you would expect in Java if you don't implement it, it just falls back to the default. And you're actually not allowed to do this unless you add this JVM default annotation. So just a bit of something you have to know to make Interop work well for your Java implementers, basically. And it's new as of 1.2, so I think it's a good thing to throw in for anyone who missed this change. Yeah, the error goes away, and now you can use the default implementation. So this one's not a JVM annotation, but it is an annotation. It's the throws annotation. You put it on a property getter, setter, or constructor, and the method header that's generated in the bytecode has a throws clause in it. So let's say you have this repository again, right, with a save function, and let's say, repositories always fail for some reason. Maybe the disk isn't available or the network isn't available, so you throw an exception in that case. That's like the method contract that we're setting up, right? If you fail to save, throw this exception. And then some Java implementer, some poor Java implementer goes to implement it and throw IO exception, and they realize that they can't because it's a checked exception in Java, and so they have to add it to their method header. But then they go to add it to their method header, and then the compiler yells at them for that because you're not allowed to add it to the method header because it's not in the interface's method header. So you've actually kind of like broken it for, this is not just a case of like ergonomics, this is a case where you can't do the correct thing in Java because you can't throw the exception that you need to adhere to this contract. So what you actually have to do is go back to your repository interface in Kotlin and add the throws annotation, and you can pass a comma-separated list of classes of exception types that should be thrown. So now your Java users will be able to throw IO exception. They'll have to put it into the method header, basically, that it throws. So basically, if you're ever writing an interface or abstract functions that should throw from Kotlin, and you have like Java users that you expect to implement it, you should probably go through and say, like, do I ever expect any exceptions to be thrown? If I do, I should put them into this throws annotation. I'm going to jump into kind of a different topic now. One of my favorite ones is extension functions and how we can make them work really well. So I've seen this happen a few times where you have a great, you have this giant Java code base, right? And you have a whole bunch of like, I've worked in Java code bases that have like hundreds of util classes, right? I'm sure we all have. And there's like important business logic tied up in those utils classes. And then you add Kotlin to your code base and you're all super happy, right? But I mean, you still have all these utils classes, and now your Kotlin has to use that business logic that's tied up in those utils classes. You're not just going to rewrite it all and like duplicate it for Kotlin just so you can use extension functions. So your Kotlin is still going to call like user utils dot something, and it's not going to read right. So something we've tried to do at previous companies I've worked at is we've asked, like, can we convert our utils to Kotlin extensions? But then you look at your code base and you realize you have like 100,000 lines, 200,000 lines of Java, and you don't want to go back and change every single call site. So can we do it and not have to change any of our Java? And it's usually possible. I haven't seen a case where it's not possible. So let's say we have this Java static utils class, right? It's a class with a bunch of static utils for user to do logical things like maybe get displayable name to return like first name, middle initial, last name, things like that. And then we have some Java call sites and we have some Kotlin call sites, right? Let's say we've just started implementing Kotlin and we realize this looks really ugly, right? We don't want to call this code the same way we're calling it in Java and Kotlin. What we really want is this. First, we're going to convert our utils over to extension functions. So I've made a bunch of them into vals because you can, but they could have all been functions as well. So this is what I really want, right? I want my functions to be nice Kotlin extension functions so that the business logic can be written in Kotlin. But then you have a whole bunch of compilation errors everywhere, right? You get compilation errors on the Kotlin side, on the Java side. So the first thing you do is obviously you go back and you make your Kotlin look the way you want it to, right? You change it to extension function syntax, which is great, but you still have all this broken Java that you've written, and it's probably hundreds of thousands of lines of Java. So the first thing you have to do is, as I said before, remember that Kotlin will export your functions to a class with kt appended at the end. So these would get, if this file were called userutils.kt, it'd become userutils.kt and then all these functions. So the first thing you have to do is specify the JVM name of this class, of this file, should be userutils, so that all these functions are attached to the userutils class. So that kind of fixes most of them, but then you'll notice like userutils.hasName is not there when it should be. So if you command space around enough, flail around and try to find these functions, you'll see that like isAnonymous is there, but then hasName is not there, and there's a function called getHasName. And so you wonder like why did this work for one thing and not for the other? So the Kotlin compiler actually does special case properties that start with the word is, and it doesn't prepend get or set to its getter or setter. It does for any other property. So for example, displayable name becomes get displayable name, and it's userutils.getDisplayable name. But isAnonymous stays isAnonymous. It doesn't become get isAnonymous. Unfortunately, like as you can see here, we have other Boolean words in English that make sense to, has, should, things like that, that we want this syntax for. We don't want to go back and change these to get has name. So one thing you can do, though, is you can actually use JVM name again. You can annotate the getter. Whoa. I've actually had this happen every time I've given a presentation. All right. Okay, so you annotate the getter, right, with JVM name. And so now what you're saying is I want this getter not to be exported as its default, which would happen to be get has name, but I want it to be exported as has name. So you can fix, usually using a combination of JVM name and file JVM name, pretty much any set of static extension functions to preserve their signatures in Java when you refactor it into Kotlin, which is great. So now you can go and convert your utils to extension functions. I'll shift gears here, and I want to touch on inline functions, a similar but different topic, I guess. But inline functions you can call a function that's inline in Java, but since the Java compiler doesn't actually support the copy and pasting of this method body, what happens is you can use those inline functions, but they don't actually get inlined, right? So the function does get put into the bytecode, but when you call it, it's not going to get inlined, and that can be really bad for performance. As I said before, there are cases where you'll call code from Kotlin and it works fine, and then you'll call that same code from Java, and what you're actually doing is maybe there's lambdas and you're allocating 1,000 lambdas a second, whereas in Kotlin, you would have inlined that method body, inlined the lambda, and gotten rid of the allocation. So there's not really anything you can do here except to try to document and make sure that your Java users don't do something on a hot code path and allocate thousands of lambdas a second, because they don't have the same inlining capabilities that we do in Kotlin. But there is one other limitation on inline functions as well. So if your inline function has a reified generic, it actually can't be called from Java. And that makes sense because there are no reified generics on the JVM. The only reason that reification is actually working is because when you inline, you're kind of just taking the concrete type that you would call that Reified generic with and replace all those type parameters with that actual class. So Reified generic functions don't work at all in Java. So like a workaround that I usually use is like, let's say you have a method that traverses a view hierarchy and looks for a view of a certain type. This is like a method I would use in Kotlin. Maybe I'm in Android and I want to find the first view that's a text view in this view hierarchy and return it. What I would do is make 2 overloads and then just call through to the second one from the first one and just grab the class instance. And then the second one can be called from Java. Maybe it would be viewUtils.firstView of type. You pass the view and then you pass like textView.class. So it looks familiar and it works for Java users. And then your Kotlin users can do view.firstView of type angle brackets text view. So just quick, easy workaround, and it makes both code bases look idiomatic, which is good. So the next topic I want to talk about is visibility, because there's a few quirks here, and I have a cool hack around visibility that I really like. So there's not like a lot to talk about because both languages have 4 visibilities and 3 of them are shared, and they do exactly what you would expect, right? So public, protected, and private work exactly as you would expect in both languages, but the ones that don't match up, so Java has package local, right? So Kotlin doesn't have package local. Luckily, Kotlin will respect Java package locals. It'll only let you call them if they're within the package that Kotlin file is in, but you can't declare new package locals in Kotlin. It's just a limitation right now. Maybe they'll add a 5th visibility, maybe not. But then the other visibility that's not shared is Kotlin's internal visibility, and Java has no equivalent to that, right? So what does that look like when you actually call into functions or classes that are internal in Java? So internal is Kotlin's module level visibility, right? So what that means is like one set of files that are compiled together, whether it's with Maven or Gradle or just like straight from the command line or anything. So you would think if you compile a Kotlin library and maybe it has an internal class and you publish it, that internal class shouldn't be seen from Java, right? That's what I would expect because it's internal. It's not meant for external users. But unfortunately, you have to think about what it becomes in the bytecode. So, right, it can't become private, obviously. It can't become package local because maybe Kotlin users in that module outside of the package need to use it. It can't become protected because maybe Kotlin users that aren't subclasses need to use it. So it has to be public in the bytecode. So all of your internal Kotlin members are going to actually become public members in the bytecode. And so you could use them from Java consumers, theoretically. Luckily, the compiler will purposely mangle the bytecode names so that you don't see it. They'll add some $ and stuff like that so that it comes out as a name that IntelliJ knows should be like way deprioritized at the bottom of the list. Hopefully your users won't use it, but you should note that they totally can, and it's legal Java for them to use it. Another thing I want to talk about is I found this cool hack to make Kotlin-only visibilities. So let's say, and you might wonder why you might want that, because like visibility shouldn't be a detail you think about when you think about language consumers. But theoretically, like let's say you have a Vue DSL, something like Anko, which is Android Vue DSL for Kotlin. They look terrible in Java, right? They don't really work. All of the fluency is lost. It makes no sense to pollute the class namespace for Java users with this DSL, right? So maybe you want to hide this DSL. So what you can do, and it looks gross, and it totally works, is you take this class name, right? Let's say I have this myViewDSL class name. First, you surround it with backticks, and surrounding with backticks in Kotlin means you can make the class name whatever you want. You can actually put a hyphen in it. So by putting a leading hyphen in it, it gets exported into the bytecode as hyphen myViewDSL, which is legal JVM bytecode, but it's not legal Java class names according to the Java language spec. So Java users can't call it. Kotlin users, I mean, it works in the bytecode, so you can totally call it from anything in theory, but the Java language spec disallows it. And then you make a type alias that points back to that class name with the hyphen and make it the class name you want. And since Java doesn't see type aliases, what you end up with is the class name you wanted in Kotlin, and you can't view this class at all in Java. And it's valid JVM bytecode. So it's a cool little Kotlin visibility hack that you can use to hide things like DSLs from Java users. So moving on, next thing I want to talk about is this slide's not a typo. It's just my least favorite character in Kotlin. So it's platform types. These are types that are basically they can hold null, and if you try to dereference them, they blow up, right? So we're back in like Java world where things are terrible and things can NPE all the time, right? Which is the worst, right? So when you call into Java, usually you'll get back a platform type. So if you've worked in Android maybe and you try to get like the intent extra on an activity or something, you get back intent exclamation point, and that means like maybe that intent's null, maybe it's not. We'll just let you figure it out. Hopefully it doesn't blow up. So I try to eliminate these aggressively, and hopefully most Kotlin users are as well. So the solution is nullability annotations. You can actually eliminate them from your Kotlin by changing your Java code. So these are changes, again, you make in Java, not in Kotlin. So let's say you have like a Java request object and you can execute it and get back a response, and that response has a value on it. And let's say I'm making like some get user request, I execute it, I grab the value and I grab the displayable name off it, and I get this horrible NP, and I go like, what happened? I thought Kotlin has no NPs, this is a terrible language. But the truth is, like, just because of platform types, well, what happened here is maybe this request failed and the response has some nullable value in it, right? Which makes sense. What you ideally want is to put a nullable annotation on this value to say to your users, hey, this could be null if this request failed. And then what happens is you notice the little squiggly there on the dot, which means Kotlin's telling you null check this before you use it, which is perfect. So let's explore like other things you can do with nullability annotations. So let's say I have this get users method and it returns a list of strings. So I've put what the type is inferred as in this comment here. So it could be a mutable or immutable list, right? Because we don't really know of strings. Each of those strings might be null or non-null, and the whole list might be null or non-null, right? So if you annotate this method with non-null or not null or some other, you can use, they're pretty flexible on what names they accept, non-null, not null. So if you annotate it with non-null, one of the nullabilities goes away, right? You know this list is going to be non-null. If you annotate, you can actually annotate as of Java 8 the type in the type parameter with non-null, and that will also make the string nullability go away. You could also use nullable here as well. And if you're on Android, as of Android Gradle plugin 3.0, you can do this even if you're not targeting API 24. You could do this all the way back to whatever version you're targeting. The Android Gradle plugin actually has a desugaring tool that will let you use Java 8 features like this, and then basically desugar them down to Java 6. So you can start annotating your type parameters too with non-null and nullable. So going back to the original code we had, we could put this nullable annotation here, right, and get null safe calls. We could put it here and get null safe calls as well. You would think maybe you could put it here and get null safe calls. For some reason that doesn't seem to work. I would expect it to, but maybe it's not. Maybe it's by design, maybe it's by accident. But anyway, I usually end up putting it here, right, nullable t when you call get value. And then usually on my other methods, I'll also put nullable. Maybe I'll put it here as well because, you know, it could be null, so I'm going to put it everywhere. But this starts to get really noisy, right? That looks terrible right now. There's 4 nullable annotations on 3 methods. So another solution to this problem is not just nullability annotations, but default nullability annotations. So these were added in 1.1.5, and you can specify an annotation not just on one member, but on a whole package or class or method. So we'll walk through a few of those. So the first thing you have to do is you have to add a dependency on JSR 305. There's a find bugs package that packages up JSR 305, so you just add a compile-only dependency on it. And then you get access to, well, the first 2 things you get, you'll notice, are these 2 really long annotation names, which are parameters are non-null by default, parameters are nullable by default. And they do exactly what they say, right? So if you annotate your package, for example, with parameters are non-null by default, every Java method's parameters in that package, Kotlin will treat as non-null. You can't pass null to that parameter. So what does annotating a package even look like, first of all? Because I didn't know this before I did this. You make a package-info.java file in that package, and then this is the whole class body. It's just like the package name, and then you put the annotations on top of it that you want. You can see I gave this talk first at KotlinConf. But yeah, you can put as many annotations as you want on top of the package name. You could put parameters are non-null by default. You could put any other package level annotations you want to put there. So, but unfortunately, JSR 305 only comes with these 2, right? It only comes with parameters are non-null and nullable. But you can actually make your own, which is great. Like, you're not limited to what they provide you out of the box because JSR 305 is a spec. So we can build our own. And I think the easiest way is just to look at the source for parameters are non-null by default. So let's take a look at parameters are non-null by default. So it's an annotation, and it's annotated with 2 meta annotations from the JSR 305 package. It's annotated with another weird variant of non-null. This one has the third n is lowercase, right? And then this type qualifier annotation, which tells you about some type qualifier, right? It tells you about like some element. So you'll notice that like this parameter that's passed to this annotation is called parameter, and you'll notice our class name is called parameter. In theory, like what happens if we change this to field now and say fields are non-null by default? So this totally works. If you make this annotation and you put it on your package, any field in a Java file in that package will be treated as non-null. Kotlin won't let you pass null, set it to null, and it won't let you treat the return value of accessing that field as null. And then similarly, you can change this non-null. You would think it would be nullable, but it's not actually nullable for some reason. JSR 305 is weirdly named spec, and you actually use this thing called check for null. So don't use nullable like I did and then get stuck for an hour wondering why it's not working. So either check for null or non-null with a lowercase third n, and then you can change the type qualifier to whatever you want, and you can make your own nullability annotations. You could say return values are nullable by default or non-null by default, right? You can use element type.method, which says like this method's return type is nullable by default, which is great because you want to treat, for example, get intent as nullable, right? You don't want to treat it as a platform type. So this is like the dream for me is all your package info.javas look like this, right? So you shouldn't be able to pass null to any parameter unless it's otherwise specified. You shouldn't be able to assume any field is not null. Maybe there's null in that value, and you shouldn't assume that any method you're calling from Java is non-null because it could have returned null to you. So this is if you want to be like super paranoid and safe. Unfortunately, the next question is like, what do I do about code that I don't control, right? So nulls and libraries, like you can't just go in and annotate their package. So how do you deal with like, for example, how do I deal with Android, right? Android has nulls everywhere. So the answer is really like you have to go talk to the library maintainers. Like a while ago, Jake Wharton added to support library 27 a whole bunch of annotations, and now the support libraries in Android are super safe. And look at all those Slack emojis. Like everyone was super happy about this. So you can also go and submit your own PRs, right? These are like really easy PRs to make actually. Annotations are pretty easy to write. You kind of just trace the method through and say, okay, you can or can't pass null here, or this method could or couldn't return null. And even if you kind of know, like maybe you're a master at Guava and you know exactly, oh, if I pass null here, the first thing it's going to do is preconditions.check non-null, right? Like it's still good to let the compiler do that for you rather than you having to know it. And it helps everyone else if you add these annotations, and then you get a whole bunch of Slack emojis like praising you for your good work on adding this annotation. So submitting your own PRs is also a great way to like start contributing into libraries you use. Those maintainers might not even know that adding these annotations helps a whole class of users, all these growing Kotlin users. So, if we all get out there and start annotating more libraries, they're more Kotlin friendly. So that's it for nulls. I want to touch on some stuff about lambdas, and SAMs are single abstract methods, or like functional interfaces, like interfaces with one abstract method. So in Kotlin, when you have a Lambda, it becomes a functional interface in Java. So Kotlin has these interfaces in its standard library, function 0, for example, for a function that takes 0 parameters and returns some type. And if it takes 1 parameter, it's a function 1, and it goes all the way up to function 23. Don't ever make a function with 23 parameters, but you can. And Java SAMs become this weird special syntax in Kotlin. So like, let's say you have a Java, like, I've seen it with onClick listener in Android. It would be onClick listener and then curly braces and then that method body of that single abstract method. So unfortunately though, if in Kotlin, if you make something that's a SAM, you make like a single abstract method interface in Kotlin, it doesn't become this SAM syntax. So right now, like SAMs actually look better when you're interoping than they do all in Kotlin. So like, let's say you have this Java essentially onClick listener, and then you make a instance of it in Kotlin. It looks great, right? It's very expressive. It's like this SAM is a Java SAM. It takes a view as a parameter, and here's what it's doing. If you go and convert this to Kotlin, you haven't really saved any lines in your implementation, and also, like, this doesn't actually work. What it ends up becoming is an anonymous object that implements this interface, and then you have to override the onClick listener. So you've gone back to like Java 6-ish syntax, right? Of like 5 lines where it should have been 1. So right now, it's not actually great to convert your SAMs to Kotlin. which is sad, but there's hope for the future, and that slide is very bright. But so they ran a survey, JetBrains ran a survey a little while ago asking what features people want the most in Kotlin. So if we zoom in a little, blue means I want this feature, red means I don't want this feature. So not a lot of features were voted against, except private members being accessible from tests, which is terrible. But anyway, so one of them that I want to focus on is SAM conversions for Kotlin interfaces, right? So that's this feature that we want, right? We want to be able to write SAMs in Kotlin and have them look good in Java and in Kotlin as well. Like, we don't want to have to use Interop just to make our Kotlin look good. So the lead language designer, Andrei Breslav, said that collection literals, which they've already started implementing, and SAM conversions are tractable. The third one he was talking about of the top three was truly immutable, like deeply immutable objects, which is a little bit harder. So hopefully, you know, there's a chance, right? We'll see this in the future, we hope. It might come soon, it might not. But another thing I want to talk about around Lambdas is their signatures. So as you saw, like Lambdas with receivers, their receiver becomes the first parameter. We saw those for extension function interop. And unfortunately, nullability of types is lost because you can't kind of express this nullability in the type parameter. So like these two Lambdas are very different. One of them takes a parameter of foo, which is non-null. The second one is an extension on foo, which is nullable, but they look the same from Java. They'll both be function1 foo comma unit. So you lose a lot of information in Java, which is unfortunate, but you'll just have to be aware of that kind of stuff. Maybe document it. Maybe instead of using a Lambda, make it like a interface so that you can really put documentation on that method. Yeah, so you lose a lot of information in your Lambdas, unfortunately, over interop. And then there's a few types that get treated a little bit specially. So most types are mapped perfectly, right? Like your own custom types are perfect. And like integers become int in Kotlin, things like that. They handle mapping of a lot of core types, but there are some types that get mapped a little bit strangely. So there's unit and nothing, and they both get mapped kind of weird. Unit is mostly fine. Like usually it becomes void, but if unit is the type of a generic, like we saw foo arrow unit as like a Lambda type, it doesn't get mapped to void because it can't, right? Because you can't put lowercase v void into a generic. You might have seen that in Java if you see like an uppercase v void where you have to like return null out of something because you can't put a primitive into a generic. It's exactly that same situation. So they choose to keep unit in that case rather than use Java's void. So you'll end up keeping void in that generic if it's a generic parameter. So for example, like function1 of foo unit, right, will become function1 foo unit in Kotlin as well. It won't become void. So what you have to do in Java is return unit.instance. You don't return null because you don't want null in Kotlin. You don't want to get back a null value. So there's actually an instance of the unit object, and you return that. Nothing is a little bit weirder. Nothing is the subtype of all other types. If you've ever used, like, Scala has this concept. A few other languages have this concept, but it's like at the bottom of the type hierarchy, and there are no instances of it. Like null is not an instance of it either, but every type is nothing is a subtype of every other type. So you can assign a nothing to a string, but there are no actual instances of it, which is weird, but it allows you to do some cool things. And it allows you to enforce this contract that if a function returns nothing, it never actually returns, right? So it either throws or loops forever. So there is no type like that in Java, unfortunately. So a few things happen. First of all, if nothing is in a generic, it just gets mapped to a raw type. So if you had a list of nothing, for example, I don't know why, but it would just become a raw list. So you kind of want to avoid that. You don't really want raw types in your Java. And an actual nothing, like a concrete type of nothing, becomes uppercase void, and your consumers just kind of have to know that they can't really, they can't expect this method that should return nothing to return. They'll have to know that it should never return. They should adhere to that contract. So a little bit of information does get lost when you're using nothing, just because that is only a concept enforced by the Kotlin compiler. So you have to be aware of that. I have one last topic I want to touch on with data classes. So data classes are tuple-like, right? And you put all your properties for the data class in the constructor, and it automatically generates hash code equals and toString, which is great. Like they work perfectly in Java, and there are no quirks around these. They also create this copy method in Kotlin. And basically what it is it's kind of like a copy constructor, right? Like you call copy on it, and then you can pass any of the parameters that are properties to that data class. And it works all right. Like you can access it in Java, but most data classes have several properties, and if you don't have default parameters, you're gonna have to pass all of them. So like going back to this user object, this is what it would look like to just like make a copy of this of this user with their points incremented by 1. That's probably more noise than it's worth to use this copy method. What you could do is you could use the copy method from the Kotlin file. You could like access the copy method using the syntax you want and just expose it to Java as a method with 1 parameter and use it as like a with-er, right? And then this is what your Java would look like. So just a quick way to, you can kind of leverage that copy method and the default and named parameters and still have a good interop story. I wouldn't like go and proactively make one of these for every property in your data class, but if you do come across a situation where you're doing essentially a with, you could make that method and kind of avoid using a gross copy method. So that's kind of all the tips I have right now, but overall, like I just want to touch on it again from like a 1,000-foot view, and interop works really well between Java and Kotlin. It's like most of the time perfect. You just have to think about a few kind of edge cases that I outlined. So when you're writing like a non-private thing in either language, it's good to say like, how does it look in either language? How will it look in the other language, right? Like if I'm writing Kotlin public classes and I ever expect Java to touch it, maybe I work in a mixed code base or I'm making a library, like just kind of imagine how it would look in the other language, or even better in my opinion is like write some tests in the other language, right? Like if you're writing a Kotlin file, you could write some Java tests. If you're writing a Java file, you could write some Kotlin tests and just kind of explore the ergonomics of your API, right? Like kind of dog food it a little bit. And I think it gives you a lot of insight into how that API will look overall. So that's pretty much it. I pulled these tips mostly from, there's 2 really good official guides on the Kotlin website. There's a guide on calling Kotlin from Java and calling Java from Kotlin. Both are kind of reference style. They're just like bullet points of like, here's a problem, how to fix it. Here's a problem, how to fix it. There's another interop guide written by the Android core team, and it's great. And it gives you more like stylistic guidelines. They go over a few that I didn't go over here. Like if you're writing a Java file, a method that has like a Lambda, put it at the end because that'll give you that nice angle bracket, curly brackets outside of the parentheses in Kotlin syntax. So they go over a few more like big stylistic choices that are good to know. It's well maintained and worth checking out, and they're all worth checking out. Yeah, that's my talk. Thanks.